Today I would like to talk about the downtime analysis service. There's a Porta offer as a service, of course, and this is typically needed when you have a loss of production in your department and you don't understand why this loss is there. So as a first step, we start from the theoretical cycle time, so what the machine should produce theoretically. And we start a mapping overview of the machine where one of our technicians is coming to your facility and for several days is mapping exactly what is happening in your department. So every stop, every loss of production, he records the event and he records also how many minutes. So he's basically collecting all the information in order to understand what is really happening in the department. Here we are looking at a real case history. So in this case, the machine, once you have all the data, you have to divide the machine efficiency with all the rest. In this case, the machine lost 1.47%, which if you take away from the 100%, which you would like to have availability of machine, we have a machine availability of 98.53%. So here you understand that with 98.5% availability machine, the machine is not the problem. So we need to go deeper and try to understand what are the loss of production, where are the loss of production. In this case, when we arrive, after reading all the data, we are having an OEE of 63.53%. So as you know, 85% is a world-class manufacturing target. 60% is typical in the manufacturing companies, and 40% is very low and not acceptable. So in our case, we are starting from a typical, having 63%, a typical situation in average. But once we have all this list of stoppage on the machine, we apply the Pareto principle, where we see the two main reasons why we are losing production. And thanks to the Pareto principle, we're going to work on these two to improve our OEE. So the first one is a tool setup. So the tool setup uses a lot of minutes, a lot of lost production, because in this case, the operator was stopping the machine and going to change the tools away by indexing the insert jaws and come back to the machine. So here you are going to see how we suggest to solve this problem. The second is the coolant. So the machine was low on coolant and there was no coolant available and a lot of time was lost. So let's see in detail, without these two, or by fixing these two main reasons, we go from 63.53% to 87.27% OEE, which is moreover than our target of 85. Let's see in detail what we suggested. Talking about tool. So the problem, the cause was working away, like I said, from the machine with the tool, changing insert, waiting on the tool room, coming back to the machine, and all this time while the machine was sitting and not producing. This operation was repeated so many times that, like I said, is the first cause of lost production. What we suggest are a redundant tool. So once the tool is at the end of life, there is a redundant tool, and with this redundant tool, basically we solve the problem and we don't have any more of this loss of production. The second cause was the coolant. So here we suggest an automatic filling of the coolant. So there is a system that once the machine coolant goes down, automatically is filling up with new coolant. So even in this case, we solve the problem. So thanks to the first two problems solved, we went from 63.53% of OEE to 87.27%. So if you are interested in applying this method also to your machines, contact us and we will be happy to send you free of charge the manual where there is all the procedure and all what you need to know in order to apply also to your machine the downtime analysis.